Okay, number 15, here we go. We know that this is a rectangle, so area of the rectangle minus the area of the circle. So this one's not a bad one to start off on. The area of a rectangle would be 21 times 4, 84, minus the area of the circle. Could be a little bit tricky, but it shouldn't be. Notice that from here to here, it's 4. That's the same as from here to here. It's 4. So we know our diameter is 4, making our radius 2. So the area of that circle is pi r squared. Pi times 2 squared. And we have now done number 15. Woo! Okay, what's going on in number 16? I always write down the strategy first. This is which figure is larger. This is area of a circle minus area of a square. We have to assume that's a square, because if it's not, we couldn't solve this problem. Okay? So let's do the area of the circle first. We just did the area of a circle with a radius of 2 in our last problem. So pi r squared, we know the area of the circle is going to be 4 pi. Now we have to find the area of the square. I recommend drawing another radius, which is also 2, 2, 2, 2 root 2. So I know that the area of the square is side squared. So 2 squared is 4. The square root of 2 squared is 2. 4 times 2 is 8. It's not 8 pi because it's just a square. Don't attach pi to everything these days, only to things that are circular. Good, 4 pi minus 8. Let's keep going. Now, in problems like this, sorry that the picture's a little off, when something looks like a semicircle, about half of a circle, you're allowed to assume it's a semicircle. Because if it was like 3/4 of a circle, we'd be in trouble. We wouldn't really know what to do. So we are allowed to assume it's a semicircle. So what is this problem? It's area of hexagon minus area of a semicircle. So we're going to have to divide the circle by 2. Don't forget that part. Okay, so area of the hexagon. Let's just dive into that one. Now, a hexagon is one of our special cases, so we don't have to use trig. In our hexagon, we always draw an apothem and a radius. Half of the side is 4. 4 is across from 30, so the apothem is 4 root 3. And now we're ready to find the area of the hexagon. Apothem times perimeter. Let's see, there's 6 sides and they're each 8 long, and then divided by 2. So we ignore the root 3, we plug everything else in our calculator. 4 times 8 times 6 divided by 2, and we get 96 root 3. We okay with that? Area of a hexagon, it's good practice. Now, area of the semicircle. So we're going to do pi r squared, but we're not going to forget to cut it in half because it's only a half circle. What is the radius of that semicircle? It is 4. So pi times 16 divided by 2. 16 divided by 2 is 8. Okay, this is number 18. This one is a little confusing because of how the picture's labeled. I didn't make this picture, I'm so sorry. This is a 30-degree angle, and this means that the radius is 4. So that could have been confusing from the start if you didn't even know what those numbers meant. This is, of course, area of a circle minus area of a triangle. Another piece of information that you didn't already know was that when an angle opens up to the diameter of a circle, it's a right angle. Every time, all the time, no matter what. We'll learn this in our circles unit. So, yes, that is a right angle right there, even though we haven't learned that yet. Okay. All right, so let's find the area of the circle first, because that, quite frankly, is going to be the easiest part of this problem. Pi r squared. Is it okay if I just write 16 pi? Okay, now area of the triangle. Base times height divided by 2. Your base and your height are the two sides that are perpendicular. Base and height. I don't care which one is which. They are interchangeable, but make sure you're using the two sides that are perpendicular. So, this side is 8. That means across from 30 is 4, and that means across from 60 is 4 root 3. So it's base times height divided by 2. So it's 16 root 3 divided by 2, which gets us 8 root 3. Do you see how all these answers are? We're keeping them exact, which means we're not combining them. We're keeping them separate unless we have like terms. 16 pi minus 8 root 3. 19, this is a good one. We're doing the area of a rectangle minus the area of, how many circles do we have? Yeah. So you can put 2.5 circles if you want. It's not like I'm going to grade your strategy. I always write the strategy at the top. That part won't be graded. You can write it however you want. 2.5, however you want to phrase that for sure. 5 halves. Okay, so the radius is 3 for all circles. So you're like, how in the world are we going to find the area of that rectangle? We need a length and a width. Don't worry, we can do it. If the radius is 3, how many radii do we have? That makes sense? 1, 2, 3, 4, 5. So this is 15. And then this is a radius. And this is a radius. So do you see where we're getting the dimensions of our rectangle? Oh, not 9, 6. I know. I was multiplying. I know. Okay. 15 times 6. So the area of our rectangle is 90. Now let's find the area of 2.5 circles. So all we have to do is find the area of one circle and multiply it by 2.5. The area of a circle is pi r squared. So we're just doing 9 times 2.5. You can keep it as a decimal, but in my typed up answers, I have it as a fraction. But if you have 22.5 pi, that would not be wrong. Once again, on number 20, you did have to know the fact that when an angle opens up to the diameter, it is a right angle. So go ahead and add that right angle marking, even though we haven't learned that yet. We've done this before. Area of a circle minus area of a triangle. The area of that circle is pi r squared. Pi, the radius is 5. So pi r squared. So the area of our circle is 25 pi. The area of the triangle, base times height divided by 2. We know the base and the height are always perpendicular. And this is a right isosceles triangle, 45, 45, 90. So we need to find the legs of that triangle, and we know we divide by root 2, and then we rationalize. But you probably already knew that it was 5 root 2. You do not have to go through all those steps if you already knew it was. So we're doing base times height divided by 2. 5 root 2 times 5 root 2 divided by 2. Okay, so let's do all this. Let me change colors. 5 times 5 is 25. Square root 2 times square root 2 is 2. Divide by 2. The 2's cancel. And you were right. 25 pi minus 25 doesn't equal 0 pi, right? Could you imagine if someone actually did subtract those? 0 pi, your answer would be 0. And we know that's not the answer. That's why we don't subtract them. Number 21. This one's going to be area of a trapezoid. I don't want to put T because I use that for triangle, huh? Minus area of a circle. We haven't done trapezoid in a while. Base 1 plus base 2 times the height divided by 2. We have base 1, we have base 2. What's the height of that trapezoid? Use the radius, hint, hint. Good. So it's 3 plus 3. If the radius is 3, it's 3 all the way around. So the height is 6. So base 1 plus base 2 times the height divided by 2. So we have 26 times 6 divided by 2. The area of the trapezoid is 78. The area of the triangle is quite easy. Pi r squared. I'm not even going to show work. Pi r squared. Whew, that one wasn't bad. Alright, so for this one, it's really area of a circle minus area of a circle. Obviously, we're going to do the larger circle minus the smaller one. We had one just like that in our notes on Friday. So, the area of the larger circle is not hard. The radius of the larger circle is 3. So it's pi r squared. It is 9 pi. Now, unfortunately, the radius of the smaller circle is a decimal because 3 is odd. So this one's going to be pi r squared. We're going to have to square 1.5. I personally am going to put it into fraction form, but you don't have to. This is the first time in this whole worksheet that we can actually combine our answers. They are like terms. You do not have to do this by hand because in geometry you're allowed to use a calculator. So 9 minus 9 fourths, and then I just do math, enter, enter. So I get 27 fourths pi. If you put 6.75 pi, that is okay too. Those are both completely acceptable. Number 23. Always write the strategy down first. Area of a square minus area of a circle. We have to assume it's a square or else we could not solve this. It is a square if a circle is circumscribed in it though. So the area of a square, that's not bad. If the radius is 6, then the diameter is 12. That happens to be the side of the square. So we know that 12 squared is 144. And then the area of the circle is also super easy. Pi r squared. 36 pi. Not bad at all. Okay. 24. Find the area of the composite figure. There's really no other way to go about this other than finding the area of each shape one at a time. We've got a triangle, we've got a rectangle, and we've got a parallelogram. I usually just find their areas and write it inside the shape and just add them together. There's no subtracting here, okay? That 16 almost got cut off, so be careful. This is 7. This is 3. So what is this will be the height. What's the height of the parallelogram? So we're going to do segment addition. 7 plus 3 plus something equals 16. So the height of that parallelogram is 6. I hope that's okay. Since it's a parallelogram, opposite sides are congruent. So we are allowed to assume if this is 9, and we know, we're not even assuming, we know that this is 9. I think we have all the information we need. Okay, for this triangle, it is base times height divided by 2. The base is 9 because we got that from the parallelogram. The height is 7 divided by 2, 31.5. Next one, rectangle, 3 times 9, base times height, 3 times 9, 27. Next one, parallelogram, base times height. Not so bad. Oh, 54, sorry. I know. And final answer, 112.5. So what is going on here? How are we going to do this one? I actually recommend on this one that we do rectangle, this rectangle, rectangle, the area of the rectangle minus, just like you said, the area of 1/4 of a circle minus the area of a triangle. That's what I would recommend on this one. So let's find the area of the rectangle. Let's see, it looks like, if the radius is 30 here, then the radius is 30 here. Do you get where I got this 30 from? Because it's the radius of the circle. So this length, the base or the height or the width, whatever you want to call it, is 90. What about over here? Well, once again, the radius of the circle is still 30. So 30 plus 30 is 60. So that rectangle is 90 by 60, 5,400. Okay, the area of 1/4 of a circle. The area of a circle is pi r squared, but we're going to divide it by 4. Forget what we get for that one. $225. Now we need to find the area of this triangle. So let's see. What's 90 minus 45? Do you see how that makes this one 45? Because it's 90 all the way across and we've used up 45. Okay, good. The whole height, we know this side is 60. So triangle is base times height divided by 2. I would consider this a K-level problem, wouldn't you? 1,350. Now we combine like terms. We are allowed to subtract the 5,400 and the 1,350. We're allowed to subtract those. So we get 4,050 minus 225 pi. And that is the final answer. Sorry, millimeters squared. On the recorded lesson. Yes, very good point. Totally just could have done a trapezoid minus 1/4 of a circle. I love when you guys see things that I don't necessarily see right away. I guess because they had this X here, I felt like I needed to find that link. I don't know. But no problem. That's great. That's better. That's faster. Good job. This one really is not as intimidating as it looks. We don't have to find the perimeter. Woo! So we just have to find the area. That's great. So let's divide this up. I would just divide it here and here. You can divide it however you want. Length times width. Let's see. Here's the length. What's the width? 2 plus 3. Does that look good? 5. Making sure. 3 by 5. 15. So we've got 9. We've got 15. And this one's 3 by 10. Whoa, that's the easiest one we've done all day. 30 plus 15 plus 9. Nice to have a mental break on that one. Last one! Woo! 27. Okay, what do we have here? Trapezoid. Trapezoid. Plus, not minus, 1.5 circles. It's a cupcake. Okay. Trapezoid plus 1.5 circles. All right, let's find the area of the trapezoid. Base 1 is 6. Okay, use that. Plus base 2, let's see. 3 plus 3 plus 3, right? 6 plus 9 times the height divided by 2. So the area of the trapezoid is 45. Okay, we want area of one circle, and then we want to multiply it by 1.5. What's the radius of one circle? It's kind of confusing because the radius is 1.5, right? Or 3/2. So pi r squared, but we don't want just one of them, we want 1.5 of them. You could also use 3/2 instead of 1.5 if you want. You're going to get 27/8 or 3.375. I don't care which one, but on my answers I have 27/8. That was ugly, sorry. This one we're adding because we're not taking anything away.